My name is Terrence Barkin, the Executive Director of the Advanced Carbons Council. If you're not familiar with the Advanced Carbons Council, we are a global trade association connecting more than 40,000 material scientists and professionals that work with advanced carbons materials. The genesis, of course, has been graphene, and that's the focus of today's webinar. And we also cover other advanced carbon materials, including carbon fiber, carbon nanotubes, and other derivatives and related materials similar to graphene. Graphene is our focus today. And with that, I'd love to introduce Dr. Dennis Wright. He is presenting today from Sparc Technologies. They have developed a formulation of graphene for coatings and paints, and we're going to hear about the technology that they've created and the impact that it has on the underlying assets that protects. And with that, Dennis, I'm happy to hand over to you if you want to take us through your presentation. Thank you.
Thanks very much for that, Terrence. And I really appreciate everybody's time and effort that they've gone to take in this presentation and allow us to share the journey that we've had over the last 6 or so years based around graphene within protective coatings initially, and now more recently in the last year or two branching out into general polymers as well. So without further ado, Sparc Technologies, 3 main things to take out of this slide are that Sparc's an Australian Stock Exchange listed company. We've got several materials that we're working on at the moment. The ecosparc product is the most commercially advanced product. We're up to trials out in the field with that. We also have a hydrogen division, which is the generation of green hydrogen via photocatalytic water splitting. And a little bit down the tree there, we've got some more recently, last year or two, working within plastics, within anti-fouling, both with graphene in those and composites as well as photocatalyst coatings and sodium-ion batteries. For the graphene materials division, we're based out of Adelaide in Australia, so hence the twangy accent, and hope that's okay and everybody can translate. Within the business, absolute privilege to work in this business. We've got more than 100 years of coatings experience in protective coatings from the team that we have. And we have a dedicated crew of people working within Adelaide that all that has been done for the last 6 years is graphene in coatings and graphene in polymers. So we've generated a fair, consistent package of data, which continues to evolve, and it is wide-reaching in the number of tests that we do, and also we're quite a humble company in the fact that if we don't have a piece of kit or we see some expertise somewhere that we could collaborate with, we do that, and as a result of that, we've got great partnerships with institutes, businesses as well, and universities, and we're part of the ITTCs and CRCs and that sort of stuff. So graphene, discovered many years ago now. There's some misconceptions about it, and I'll address those because not everybody on the call will have been sort of in the game. 10 years ago, expensive, and there are still some grades expensive today. We've actually assessed graphene that's sort of $15,000 a kilogram, but that's never going to get into a protective coating because it's just too costly. But alongside of that now, especially in more recent times, there's much more cost-efficient methodologies of manufacture of graphene, and there are sources of graphene out there that do hit a price point performance ratio that make it viable to put it into a commercial setting in industry. There's quite a few challenges associated, including the cost one. That's a very technical sort of observation, but cost is a technical property, and we've overcome those challenges, and it has taken a lot of hours of work, hundreds and thousands of hours of work, to get graphene into protective coatings, so that we can talk to the data, and we're a data-driven company, with the customers and the clients that we want to deal with. Once we've generated that knowledge, coatings are just really thin polymers with a whole heap of other materials thrown into them. And so we're leveraging on that knowledge because polymers behave generally in predictable ways, and working out into polymer composites and as recently as yesterday, good results in a certain composite that we're working in. at quite a low percentage of graphene as well, which talks to that cost. So challenge number one, selection in graphene and characterization thereof. Coming from the Graphene Council website, actually, initially, there's quite a lot of variables associated with graphene. Layers, size, particle size, impurities, method of manufacture, turbostratic versus stacked square, and all these play into the physical properties that graphene imparts onto the materials that it gets put in. So step number one, you have to be particular for the grade of graphene that you search for and want to use. We don't make graphene. We utilize graphene from all around the world, and to that end, there is about 750 sources of graphene available in the world, and we've assessed many of them, hundreds, in various applications. And again, there is no bad source of graphene. There is just graphenes that are useful and applicable to specific situations and industrial needs. So that's our attitude when we come into it. Another challenge with graphene is that it agglomerates and settles out. It wants to do that, especially straight graphene, not graphene oxide, or with a high percentage of oxygen in there somehow, or argo, reduced graphene oxide. Through all that work and the hundreds of grades that we've looked at, we've actually got about 5 that work in protective coatings well and reliably. That means that we've got a hit ratio of about somewhere between 2.5% and 5%, or even lower than that. So when people historically have looked at graphene and have said, this doesn't work, there's a high likelihood that they just haven't had a grade that works. That's the challenge. So the long-term stable dispersion, picture on the left there, that picture on the left is agglomerated graphene. It's not happy. And if you put that into a coating and you couldn't tell that that's what it had done, and you did some corrosion testing on it, you would get terrible results. That wouldn't be any different from your standard. It probably wouldn't damage your results at all, but it would just be equivalent to what normally corrosion resistance or scribe creep that you would get out of the standard cyclic 12944. The material on the right-hand side, however, that's 94% dispersed. It's not a full dispersion. It's very, very hard to get a full dispersion at 100%. That 94%, that's typical from what we get. Now, even this little piece here, that took us 6 months to work out how to do. Because we wanted to know and wanted to understand the functionality of it and what we were seeing and how it was working. We've actually got videos of graphene as it cures in a coating agglomerating. And when it does that, it's just not going to help you out. And that goes across applications, not just protective coatings as well. This is a little video. It's a pictorial demonstration. It's real. Those are both the same commercially available coating from industry. We just went down to the local protective coating store and bought some. The one on the right is our graphene-based additive, and the one on the left is straight graphene. You can see from that, it doesn't want to go in, it doesn't want to wet out. Typically, the addition of our graphene-based additive is in the letdown phase or the later stages of manufacture of the coating. You can't do it as a post-add because that mucks around with the ratio of materials of the polymers in the curing in the A and the B pack. Once we've done that, for solvent-based coatings, 2 years ago, we started working on water-based materials as well. And this demonstrates, this is a fairly recent video, only a couple of months old, our recent success in our ability to make a stable dispersion in water of graphene. That's actually really cool because that's actually quite hard to do. And it's a credit to the guys here who've just done a mountain of work across the board in the dispersion in both the solvent-based materials and the water-based materials. We've now got good results in water-based for corrosion resistance. How does it happen? That's a really good question and one that we've wrestled with. And again, we're humble in this, that there is argument out there about layering and lamellar structures, and we don't discount that at all. And we've also got some of our ideas that we offer up to the table. What this is a wine rack analogy, and that's a folding wine rack that folds up like a piece of lattice. And the thought process is that if you've got a single layer of graphene, it's sp2 hybridized, it's got a little bit of flex in it for those single layers or few layers, graphenes or FLGs. Once you get up to a larger number of layers, like a phone book, so a single page out of a phone book, it's quite flexible. You can bend it a bit. It's got a bit of give in it. Once you get up to a full phone book of layers of pages, it's nowhere near as flexible or pliant. And what we think is going on, or what we propose, and we've got a fair bit of evidence that supports it, is that the graphene is acting as a shock absorber within the coating and within the polymer. That means that it is taking up some of the stress. And what we've got on there is a picture on the right-hand side of a solid epoxy polymer cured with a polyamide. There is just graphene and just polymer A plus B in there. And when we put that under stress and broke it, what we found was that the graphene stopped the crack lines through the polymer. Now, that in itself is an indicator. It's not a conclusion or the panacea of all woes or anything like that, but it's a very strong indicator about how graphene is working to take up the stress within the coating. We'll talk to data in a minute, and I realize this is a very high level and moderately fast presentation. Happy to talk to anybody offline as well, so feel free to reach out. What we've got is a core data set. We've got 6 years worth of epoxy data and results, and that was the genesis of this business initially. And as I've said before, in the last couple of years, utilizing that knowledge that we have, we've branched out into some anti-fouling work that we're ongoing with and working with university with at the moment, and beginning to collaborate, and also working in solid dispersions of graphene, that is solid polymers and composites. And to that end, we've just signed a collaboration agreement with a packaging company that we're going to be working with to improve their packaging and making it more sustainable and environmentally friendly. Our profile as a company and what we do is of that ilk. That's what we're trying to do. So ecosparc, biosparc, polysparc, what we've got around the outside of the ring there, that they're coatings. And that's what we've done a fair bit of work in. We've focused on epoxy coatings, and we're using that now to branch out into other polymers that makes sense to work it in. We're not just releasing product and saying, here, market, go and use it. Our attitude is to go and find a problem and see if graphene within a polymer can solve and address that problem, whatever that may be. Data on the ecosparc, and that's what we're going to be looking at in the next few slides. And this is a quick introduction to it. We're data-driven, as said before. It's a drop-in based, graphene-based additive that mixes in as per the video. We can cater the polymer that it's in to the polymer that's in the coating. So if it's bisphenol A, that's great. If it's bisphenol F, that's great. If it's a blend of the two, that's great. We've got a product family that addresses that. And we've also got the material or graphene dispersed in a number of other polymers as well, so that the polymer of use is indigenous, or it comes from, as best possible, the polymer that is within the coating system, because that means that all the customer is putting in is the graphene, and they're pulling out a little bit of polymer to take into the account that the polymer that comes in with the additive. It addresses the brittleness and it improves the anti-corrosive properties of it. There's a cause and effect there. The effect is the anti-corrosive properties are improved. The cause is it's actually supporting the polymer film or the coating film on the steel. That gives an apparent improvement in adhesion, improvement in flexibility, but the upshot of that, improvement in crack resistance, but the upshot of that is that you get an improvement in the corrosion resistance that you see as tested by Scribe Creek. We're not a graphene manufacturer. We use graphene from around the world. We're agnostic is probably the word to use for that. And we look for the best graphene sources that we can get to do the jobs that are required by our customers. This is the development pathway. Put this up. It is the development pathway of ecosparc, but it's also of our business. They're very closely related. We started in 2020, University of Adelaide, worked out of University of Adelaide for a while. The wisdom of the people that started this business, I always talk about that because we set up to do ISO 12944 as the main one, but we can do salt spray, we can do dispersions, we can make paint, we have the expertise to do that, we can test it under a number of test methods, which generated the initial data that meant that when we started talking to customers 2 years later, after we got testing done, then we were talking with the right language and the right data points. We established a commercial manufacturing plant in 2023 where we can service industry. We can make enough graphene additive to go into paint lines, no problems at all, making our plate manufacturers, we could supply enough graphene-based additive to go into millions and millions of liters of coating, so that's good. And in 2024, working with asset owners, well, we commenced field trials via a collaboration with a paint manufacturer, and we've got field trials underway now. This year, very excited to be participating in this, and a lot of work went into it over the journey to be certified to the 3 ISO standards. And that's really in preparation of a significant growth and getting our systems in place and also recognized that we can participate in the global market in a serious way. Next year, the goal is adoption. I mean, we're a commercial business, and so the goal is commercial acceptance and adoption FY26. This slide, the point of this slide is to demonstrate the amount of work that we've done. So rounds A to I there, round A 5 or 6 years ago, that's 9 rounds of 12944 type testing. For those who aren't actively within paint, that's a 6-month test, 4,200 hours, hundreds of panels. We do things as per standard, duplicate, triplicate as necessary, scribe creep measurements. And so we've gone through that process 9 times. The data that we generate out of each of them feeds into the next generation of work that we're doing or confirms with internal standards between rounds. I know there's a lot of mouthful there, but that's just how it works. And on the right-hand side of the screen there, you can see the other ISO tests that we do that are supporting data. Some of it's mandrel testing, some of it's other scribe creep like adhesion work, some of it's crack resistance testing. There's a whole stack of material that we generate so that we understand what's going on with whatever we're working with. We think we've got a significant body of data that we can fall back on and talk to, as you can see from this very short presentation, and we're happy to extrapolate out and expand out on that as we need to, and no problems at all. The other part of that is you can see we don't shy away. We don't put up, oh, it's wonderful every time. We've got a heap of good, consistent data there, and there is variations in it a little bit, and some of that is due to the coatings that it's put in, and some of that is due to the extent of time. There's a couple there that people will see that are 1,000 hours, not 4,200. It's a slightly shorter test. You get a slightly different set of results, and you're looking for different things. But overall, we get good, consistent data with significant improvements in scribe creep and corrosion resistance. Interestingly, if you look at round number I there, we've got a 28 and a 47% improvement. That was based on a commercially made coating. And if we look at that, that's also correlates out into this crack testing. So we had an improvement in the scribe creep. So that's great. So we said, righto, what's going on here? And we proposed, as we have for a number of years, that there is a reinforcement of the film via shock absorption or stress absorption by the polymer. So to test that, we've done 2 rounds of crack testing, 100 test pieces each one in triplicate. The first round we did, right-hand side there, 252 cycles as per TM404, And we saw in a coating, we saw with graphene at the right percentage, no cracking and no graphene cracking. This test goes from -30 to 60 degrees, 252 times. So we thought, well, we haven't tested the graphene to failure, so let's do that. So we grabbed a commercial coating that was commercially made with graphene, with ecosparc in it, with the ecosparc additive in it, and with that ecosparc additive, through that crack test, it lasted 32% longer to failure. We then had that coating and added more ecosparc to it, and that ecosparc addition caused an even further increase in the crack resistance in the number of cycles. So this coating has gone through 296 cycles before failure relative to the reference without graphene in it at 200 cycles. And so that's a significant increase. And whether it's 48 or 52 or 38%, it's still a significant increase. And that correlates out to a piece of steel on somebody's industry, or in the heat or in the sun, cooling down and heating up on an oil rig somewhere. It's going to improve how that steel behaves and how the coating on that steel behaves and mitigate corrosion, sorry. Once we've got that work done, and this has been work that's been burbling on in the background, we've been trying to improve our understanding of water-based coatings, starting off with just straight polymers. And so we did that. It took us a couple of years to get a handle on the grades of graphene to work, what you need to do in the coating, how you need to treat the coating. And then a few months ago, better part of a year ago now, 2-pack acrylic epoxy coating. We put some grades of graphene into it up against a standard via REAP testing, R-E-A-P, so it's an accelerated test. And from that, we got some excellent results. We can pass out the reference material and the reference notes according to this. So we got significant improvements at 0.1% of graphene in there. That's the other piece. Quickly touch on that. Depending on the coating and depending on the solids of the coating and the brittleness of the initial coating, changes your grade of graphene and the percentage you want to put in it. We start off as, if you've got something that's about 70%-ish, you go with about 0.1. So that's our starting point. If you put too much ecosparc in or graphene-based additive in, you will damage the performance of the coating. The performance actually goes down. If you don't put enough in, then there's space there for improvement. So there's a sweet spot around the 0.1. It might be 0.07, it might be 0.125. For that previous slide, we actually saw, or you saw, we started at 0.1, but we actually think for that particular material, the number's 0.125 is the right spot. And those subtle differences and the quantity of work that we've done mean that we can actually say that with some authority and say, no, that's wrong. We've done this 5 times before in a similar way with a similar solids or flexibility. This is where it should be for a starting point. So for this one, the water-based, we've started at 0.1. Once we got the good indicative results, we then got a commercial coating, 2-pack epoxy water-based coating again, and we added graphene-based additive into it. And in the REAP testing again, the accelerated testing, it's via an EIS procedure. We got a significant improvement in the performance. The next obvious step is, okay, that's accelerated. Let's put it into a salt spray set of tests, and that's what's underway right now. We're doing that right now. As a follow-up to the work that we've done within the lab, we're a commercial business. We're trying to commercialize the product. And so we're working in collaboration with a number of significant asset owners. And we found that there's actually a good appetite for improvement in corrosion performance on their coatings with those asset owners. Our goal with them is to, one, de-risk the utilization of ecosparc into coatings, because there's 2 parts to development. One is you want to make sure it works and it does what you think it's going to do. And the other one is you want to make sure it doesn't damage the performance of your coating in any way. In the lab, we're confident, and we've done that across a range of ISO tests. The rubber hitting the road is putting it out in the field on steel, within mining and oil and gas industry, and also on standard infrastructure. And what you can see there is a variety of tests, and there's ongoing work now to put it onto more infrastructure of various kinds in various situations, C2 to C5X, to understand and make sure that it does what we think it's going to do. When we're working with their asset owners, we're actually upfront about we want to be included on the spec, and I've personally been quite surprised at their appetite or acquiescence to going, yes, if your material works, that is a good idea, because we want to improve the longevity of our steel and the amount of maintenance that we have to do. So it's a multi-pronged sort of work through that we're participating right now, and we're happy to say we're being supported by a number of coatings companies in a number of ways, including with the manufacture of batches of graphene-based additive containing coating now. So the value proposition, there's hundreds and hundreds of sources of graphene out there. They are all good for something. Some will be good for tires or tennis rackets or anti-static coatings. It depends on what you want to do. We've evaluated hundreds of grades of graphene. A very small percentage of those hundreds of grades works within protective coatings. We know the reasons why it works, and we understand that. Hence that we're now getting reliably good results of scribe creep corrosion, and also the other supporting tests that we do to demonstrate that. We talk the language of the businesses that we're dealing with, and we make the effort to do that. And we're also happy to collaborate and do work with businesses at their behest, and we are commercial at the same time. We're ready to go with manufacturing this week, and we are making batches of material for field trials, and they're going out onto field trials currently. All right, Terence, back to you. Thank you very much, everybody, for listening, and looking forward to some questions.
Dennis, thank you very much. And when we send out the slides to everybody, we'll make sure that we include your contact information there.
Yep.
Let me just put this side by side. That's better now. So first of all, Dennis, I just want to share an observation. I think you hit on some points that we as the Advanced Carbons Council, as an independent third party, but they have been tracking graphene for over a decade now, 100% agree with you. We've inventoried over 800 forms of graphene. It's very complex. You're absolutely correct. A lot of people have used graphene, and we often hear the question, why isn't it used already, or why didn't it work? And the devil's in the details, as you have noted. So just as a third-party validation, I think you're absolutely 100% correct. I think for the audience to also understand that graphene production has scaled. There's no shortage of material. The prices have become much more competitive. And thirdly, or at least another point, as you've illustrated very well in your presentation, it requires an extremely small amount, 0.1%, by weight. And so even if the price is relatively high, and it's not any longer, but even if it were, the impact on the end product is minuscule, or is offset by all the advantages. So I think you've got a really compelling story to tell. And the other point I want to just reiterate here is, there's high expectations for graphene, but the skill is in unlocking its properties. And that's the hard grift that you guys have had to go through to get to your product. So let's get to some questions from the audience. The first one was where you had the nice illustration of the dispersion, and there was a 20% and a 94% dispersion. And the question was just, how do you measure it? I believe there was a small footnote on that slide
there was,
that explained it, but do you want to answer that?
Yeah, sure. That's a really good question. We've done that by visual visual means scaling the photos to exactly the same. So those two photos were scaled to exactly the same size. We then said anything more than double the size of the particle size of the graphene was agglomerated. And then we went through and sorted that picture via not by a machine visual assessment and visual learning and classified it out. And we've now actually just got a program where we can take a photo, sub it in, and it gives a number.
Excellent. The next question, and this is a very hot topic, is the use in thermoplastics. We know that, obviously thermoset resins and polymers are quite popular, but thermoplastics are gaining a lot of traction.
Yep.
Talk about the work that you guys have done with thermoplastics, things like HDPE,
Yep.
maybe polypropylene or other
Sure.
thermoplastics.
Sure. That's a really interesting one. And so the question there is, what are you going to improve? And we've seen reliable improvement in strength, tensile strength, break strength, and and also conductivity, and we can also correlate conductivity in there as well. So if somebody wants to have an ESD type plastic, yes, okay, you can do that. If somebody wants to have a plastic that has, and I'm talking about a variety of plastics here, polyeth, polyprop, some urethanes, and also bioplastics in PHA and the like. And PHA is a great big family of plastics as well. And so the work that we've got says that you can increase strength, and depending on what you're doing, you can actually also increase flexibility, which goes against my brain, it has to be said. So we actually got some results yesterday, even yesterday, where we had an increase in elongation that was quite significant, like high at a low dosage of graphene. So it's really particular to what you want to get done and how you want to do it. And here's another one, a mind bender for us both, Terence, in that we've got a grade of graphene that we've been testing, and it kills conductivity. So it's graphene, 100% is graphene, but you put it into a plastic and you can kill off conductivity. You can put it in with a conducting grade of graphene and you can kill off conductivity. So that one, it's at odds in my head at the moment. We're working through that. But the important point is, you can put graphene in at a percentage and you can change the properties that you have that you're getting out. So it's finding the problem to solve. What do you want? What's the problem the customer wants to solve? And what property do you want to change to make graphene of benefit to that polymer?
So Dennis, your comment about the conductivity kind of triggered a question for me. We'll come back to some more of the audience questions here. But we know, in speaking with, let me just say, mainstream paint companies over the years, they were quite hesitant to even look at graphene, because he said the last thing they want to do is put a highly conductive material.
Yeah. Good question. Yeah.
Right. And
Yep.
so I think there's a misconception, because, of course, everybody talking about graphene is how electrically conductive it is, but how we're putting it in a paint. Can you just talk about that, the dichotomy there between a highly conductive material and now using it at this low percentage in a protective coating?
Yeah, definitely can. Not a problem there at all. So if we go straight to the percentage loading and the conductivity readings that you see, and we've taken hundreds to thousands and thousands of conductivity measurements, you don't see a significant impact on the conductivity of, say, an epoxy that's basically an insulator until you start loading it up a bit. So down at the levels of the 0.1%, where you're seeing physical properties manifested significantly, that is corrosion resistance, we don't see an impact on the conductivity at all. So, and we back that up, us and we've had it done externally as well via cathodic despondent testing, cathodic protection, and there aren't issues seen there. It works okay. So that concern, and it's a fair and legit question too, because if all of a sudden your paint's conducting electricity and then your steel acts as an anode, that's a very bad thing to happen. And the addition of that low percentage of graphene does not do that.
Absolutely. And, again, we do a lot of third-party testing ourselves as the Advanced Carbons Council, also in thermoplastics, thermosets, some of these other materials. And you do need to load it up quite high to get to a electrically conductive material. Which is just not the case in the way that you're using it.
Correct.
There's two questions here that are kind of related. One is just asking what the temperature was for the cycle testing results. That was on slide 15, so I'm not sure exactly which of those tests, but
Yep.
but basically at what temperature were you doing some of these tests? And then the related question is, does graphene extend the operating temperature range of the material? How does it affect how the material behaves at higher temperatures
Okay, so
or
I-
pressure?
yeah, so I'd have to go back and check exactly what that was, but according to the standard, so 12944 Annex B or the 2340 standard, so 50, but I'd have to go and double check it. So that's the first piece. We do the tests according to the standards, and so it's whatever that was. The next piece on I'll roll that question into two questions. One is temperature resistance, and the other one is chemical resistance. So temperature resistance of an overall coating, that's really governed by your polymer. Graphene will conduct heat a little bit better, but it depends on what you're trying to do. We have not seen a significant impact on temperature resistance via the addition of graphene at 0.1%. We haven't tested it hard either. We're more interested in corrosion to this point in time. I would say that it supports the polymer better. So you're going to see slight improvements in it because it's going to conduct heat away faster. And also it's going to support the polymer better. And I'd also say that for chemical resistance. We've had the question a number of times over the journey. Does graphene improve the chemical resistance of a coating? Inside a tank or inside a pipe or something like that? My response to that would be that graphene improves the performance of the polymer from a physical aspect, so cooling down and heating up and the cyclic of that, which actually damages those coatings inside tanks as much as anything else. And so the actual chemical resistance, 0.1% of a carbon-based material into a polymer, and I upgrade your polymer would be my first response. But my second response would be, if you're seeing temperature fluctuations or if you're seeing stress on your coating, the graphene will support the coating, and so you'll see an increase in improvement, but probably not due to straight chemical resistance, probably more due to the polymer behaving better and thus less cracking and then less delamination or rust or corrosion or whatever's going to go on with it. So that would be my response to that.
Excellent, thank you, and that makes a lot of sense. There's a particular question from a student or a scholar, and it's a combined number of questions. One is asking about using reduced graphene oxide or graphene hybrid materials in protective coatings and polymers. And then also asking about, since you've tested so many materials, there is graphene that is made from biomass. We have graphene made from biochar. We have graphene made from many different source materials these days. Can you talk a little bit about that? And I know you guys have done some work on LCA for your material.
So that's a really good group of questions. I'll address them as best I can, piece by piece. If you see graphene, pure graphene, so single layer graphene made by CVD, carbon vapor deposition, we've tested that. It works really, really well. As soon as you start loading up the number of layers beyond a certain number, you start to potentially have challenges. As soon as you start damaging that sp2 hybridized matrix, that is the layer, for want of a better word, that decreases the performance as well. So using those other materials, argo, etc., we think that the percentage of material you'd have to use is more, and you're not as likely to get as good a results. So we've focused on graphene because that's what we know well, and that's what is quite accessible at the right commercial quantities and cost efficiencies throughout the world. And we've been able to get good results on that. Could you use the others, and can you use the others? Yes, there's literature out there that says you can, absolutely. We've focused on straight graphene itself and worked out how to make it stable within a coating matrix or a polymer matrix. The second part of that question was the bio question, and that's also good. We've tested biologically derived sources of graphene, and that's really interesting. Yes, we've got some good results out of that as well. it's a morphology question and what it looks like question from a physical aspect, as well as the conductivity. So when you create graphene via, say, a baking method or a microwave method, uh, and it comes with its own set of properties, you know, the shape of it, the size of it, and depending on how you treat it, then you get a certain structure out of it. That structure has a huge impact, which sort of makes sense on how it supports the polymer. If it's wrong, you don't get a result at all. It's just a bit of black stuff inside your coating. If you get it right, then yes, you do get performance benefits.
Yeah, this is fascinating. I have to say, Dennis, I think for the most part, a lot of people, even people who are quite knowledgeable about graphene, don't really appreciate, I think, how important that primary particle morphology is to the
Yeah.
performance. And they're so different, right? We see they're all graphene, it's all sp2 bonded carbon, but
Yep.
the morphologies are quite different. And this kind of relates to the next question. Somebody's asking about laser induced graphene, which of course, there's more than a dozen ways of making this stuff
Yeah.
than a
Yeah.
dozen feedstock. My
Yeah.
my personal reaction is I think the laser induced graphene right now is more of a, I don't want to say a novelty, but it's not really a scalable high volume production methodology as much. And
Yeah.
I want to wrap this in to another question for you, because we've observed there's a lot of new hydrogen production coming online.
I was going to go there. Yep.
There's a tremendous amount of physical carbon as a byproduct of that process. And
Yep.
a lot of these hydrogen producers, shockingly to me, don't really have a plan for that material. And they're saying, can we turn it into graphene? And
Yep.
and so that's a question. What's your response to different types of production method and then these high volumes of material coming online?
Yeah. And so again, agnostic as to the production method, not preferred one over the other. The interesting piece is, as you commented, it's morphology, but it's in addition to morphology, it's where are the oxygens that are on there, if there are some? What are they hanging off? Are they hanging off the edges or are they superfacial? How many layers you've got? Is it turbostrate? So there's a whole lot of properties that you get out of material that then have to be happy to be dispersed into a polymer and stay stable in that polymer for a couple of years and then be put into a coating and then work in the coating. And so it's a case by case basis, but what we are now understanding and learning every week is that there's a family of properties that you need to step around and work with that give you the benefits that we want to do. So our hit rate compared to 5, 6 years ago is much, much higher, because if somebody said, oh, here's a grade of graphene, this is what it does and this is what it looks like, we'd say, thanks very much. That looks great. It's not applicable to protective coatings, but it might be applicable to this application and this application from our knowledge in those other applications as well. So it depends on where it gets streamed out to, is our attitude on it.
Absolutely. I couldn't agree with you more. There's not good or bad graphene. It's just
No.
graphene for the particular application.
Yep.
One of the things we've seen often with coatings is an explanation that graphene is creating this tortuous path. And
Yeah.
right. And if I listen to your presentation and your approach, that's not what I'm hearing necessarily. It's more that it's improving the base polymer and not
Yep.
really creating a barrier itself. What's your view on that?
Yeah, that's a really interesting one. I don't 100% disagree with the torturous path one. There is something in there, and so I'm not saying, oh, our way is the only way, and this is what we've seen. But we've got a proposed theory, the data that we generate, and we've hammered that theory, and so far all the data we've generated and the testing that we've done stacks up. There is also a bit of evidence out there about torturous path, but on the other side, it's not like in coatings land you're putting 13% MIO into a coating, which is 100% torturous path. You know, you've got so many particles in there that are huge, it's got to be torturous path. I'd say on the graphene one, there's more to it than just that, and there's definite multiple things going on in there.
Excellent. I'm conscious of the time. I'm also conscious we still have quite a few questions here. Some of them I don't think you can answer, or I assume you wouldn't, is, would you disclose exactly what type of graphene you use and everything
No,
else? I think that's pretty
no.
proprietary. and
Yep.
whether it was graphene oxide or reduced graphene oxide. What I'd like to do is kind of to make a statement, and we'll continue with some more questions as long as people are interested to hang on. I think your presentation, and without naming other companies, there are companies that have brought graphene enhanced coatings to the market, and they're in the market today. And I think for a company like yours, that's only a good thing, that you're not the only one. But obviously, you have good, solid, repeatable data. You have a drop-in solution. You can work with the paint manufacturers. From a business case, I'd be curious to hear what your view is on the asset owner versus a paint company, because
Yeah.
a
Yeah.
lot of people would say, why in the world would a paint company want to make a paint that lasts 20 years instead of 10? And
Yeah.
if you're an asset owner, you'd say, I'd like it to last 30 years.
Yeah, that's a really interesting one. And if you'd asked me this 5 years ago, I probably would have given you a very different answer. Um, but the interesting thing is, if you look at it on a sustainability point of view, how many times do you want to blast all that coating off? How many times do you want to have all that embodied energy in your coating from a life cycle analysis point of view? I'm going to go noble here, for the future of the planet. And if you say, well, it's just one bridge or it's one whatever, yeah, but if everybody does that, then our kids are going to have a better world to live in. And so if you can make a coating last longer, perform better, there's a few things to it. Yes, you're going to save money. That's great. Yes, you're going to do some sustainability good. That's also good. And so the piece I have found surprising to me as a professional person working in the industry for the last 25 years is the appetite for it, and that is changing compared to what it was, say, 5 to 10 years ago. The appetite to make the material or the steel infrastructure within the mining business or the oil and gas business last longer and less maintenance events, if we go down that path, via the improvement of a coating, and graphene participates in that and does well. I think we've demonstrated that is growing. And as I'm going to say it, the new kids come out of school and get into the positions of, sustainability manager or how do we improve it, that appetite is becoming stronger and to be aware of. And yes, we're participating in that. Yep.
Excellent. No, I think that's absolutely correct. My kind of take on this is, we didn't get into this mess in one fell swoop. We did it little
Yeah.
by little by little
Yeah.
and accumulating. And I think the way we're going to get out of this is improving everywhere we possibly can
Yep.
to improve longevity of our assets and also reduce the embedded carbon. Absolutely 100%.
Yeah.
One question that often comes up, and it depends on whether this is, a surface coating or a decorative coating, or if this is a primer or just a protective layer, is on the issue of color. Because,
Yep.
just like Henry Ford said, you can have any kind of
It's all
graphic
good
on
as
as long
long
as
as
it's
it's black. Yeah. Good
So,
on Henry. Yeah.
but
Yeah.
just in the videos that you demonstrated with the mixing,
Yep.
it didn't, there was no obvious visual impairment to the color there. But how much does it
Yep.
change the hue by adding such a small amount?
Yeah. This is an interesting one. So if you look and go and Google, what does graphene look like? And you go and find the number and it says, oh, graphene's 97% translucent. And you go, oh, great.
Right.
It's going to be clear. And the answer to that is no, it's black. But what's interesting is that different grades of graphene, depending on the properties that we, our business, sort of understand, or not sort of do understand, it gives you a certain strength of black and a tone of black. So like in the world of black carbon pigments, graphene has its own family. How much does it change color at 0.1%? It does change the shade, and depending on the color that you're putting it into, can change the color, and you do have to be aware of that and upfront with that. But is it going to turn a white into a black? No, it turns it into an off-white. And so it's not super significant. And to note, the materials that graphene goes into with epoxy coatings, they're either usually top coated, and so zero issue, or they're used and they weather naturally anyway. So would I go and put graphene into a pristine white automotive application and expect it not to do anything? No, I wouldn't do that. Would I say to people, you can put it into epoxies and it's not going to have a huge impact, and qualify it a little bit and have discussions around it? Yes, I would do that, but it's not significant.
I hear you. To paraphrase, it's not a game changer. And
No.
especially if you're protecting industrial assets, the
Yep.
aesthetic is not the primary objective, right?
Yep.
Excellent. Well, I appreciate your time, and I think you've certainly come with the receipts for the data on what you can demonstrate, and it's very
Thank you.
impressive. And the other thing I think that's really important, this isn't theoretical. It's not over the horizon. This is available now. It's available at volume. And so, and I would just say to those in the audience that are considering this, it is available now because this is a proven technology that we've seen this, and it's also been proven from other suppliers, similar but not the same as what Sparc has presented here. Certainly encourage you, if we didn't answer your particular question, to reach out to Dennis and to reach out to the team at Sparc and learn more about this. If you have any questions just in general about graphene or any advanced carbons, and you want some independent third-party feedback from us, that's what we do. And we're here, and we really appreciate having Sparc as a member in the Advanced Carbons Council and the work that you guys are doing. We're glad to be able to have you give your presentation today. So thank you for that, Dennis.
Thank you very much for everybody attending, and thank you for the time and the privilege of doing it.
Excellent. Thank you. Take care. Thank you to
Thanks,
everyone.
guys.
Have a great day.